All right, silly people, here's the situation. Uh, what we're going to do in this one is we're going to uh, basically set up the characteristic equation to find the eigenvalues. We don't actually have to find them, though. We just have to make some observations about the characteristic equation itself. And so right now, it's most useful to just go ahead and calculate a few things. So one of those is being the trace of this matrix. So that's pretty easy. You just add up all the diagonal components and you get T11 plus T22 plus T33 for the trace of T. Uh, Also, it's useful to go ahead and calculate the determinant of this. So uh, this is going to be a little bit more of an involved term than the trace, but we can do it once I finish writing out the matrix. So the determinant is going to be T11, T22, T2 or 3 plus T12, T23, T31 plus T13, T21 plus T2 or it's actually T21 times T32. My goodness, T32. And then also minus T31, T22, T13, minus T32, T23, T11, minus T33, T21, T12. Okay, so that's the determinant. Now we can start setting up the characteristic equation. The determinant of our matrix T minus lambda times the identity matrix is equal to 0. So in other words, the determinant of T11 minus lambda, T21, T31, T12, T22 minus lambda, T32, T13, T23, T33 minus lambda. The determinant of that matrix is 0. So it's T11 minus lambda times T22 minus lambda times T33 minus lambda minus T, or actually, let me add the other positive terms, T12, T23, T31 plus T13, T21, T32. Now we're doing minus T31 times T22 minus lambda times T13 minus T32, T23, T11 minus lambda minus T33 minus lambda times T21, T12 equals 0. It's pretty useful to start trying to expand the three multiplied components. So I'm just going to do the first couple of those. So you get T11 times T22 minus lambda times T11 minus lambda times T22 plus lambda squared all times T33 minus lambda, and then the rest of the terms, so T12, T23, T31 plus T13, T21, T32 minus T31, T22, T13 plus T31, T13 lambda minus T32, T23, T11 plus T32, T23 lambda minus T33, T21, T12 plus T21, T12 lambda. That should be all the terms. Um, so now I'm going to expand the things in parentheses again, and then have to write out all the other stuff, but I am just going to copy and paste a lot of it. So it's going to be T11, T22, T33, minus T11, T22 lambda, uh, and then minus lambda T11, T33, plus lambda squared T11, minus lambda T22, T33, plus lambda squared T22, plus lambda squared T33, minus lambda cubed, and then the rest of the terms, which I'm going to copy paste. So see you in a second. So there's all of the terms expanded out as much as possible. Now we're going to recollect them like the characteristic equation A73. So that's just saying we're going to have a C3 times lambda cubed plus C2 lambda squared plus C1 lambda to the 1 plus C0 lambda to the 0 equals 0. So grouping it together like that, the only term which is on lambda cubed is a minus 1. So we just have minus 1 lambda cubed. That is for sure. Lambda squared terms are going to be T22 plus T11 plus T33. That's it. That's the lambda squared terms. The lambda to the 1 terms, there's a bit more of those because we have a minus T11 T22 minus T11 T33 minus T22 T33 plus T31 T13 plus T32 T23 plus T21 T12, and that's the lambda to the 1 stuff. And then you have all of the other terms, which are multiplied by lambda to the 0, starting with T11, T22, T33, plus T12, T23, T31, plus T13, T21, T32, minus T31, T22, T13, minus T32, T23, T11, minus T33, T21, T12. That's it. So that's the whole characteristic equation. The thing that we were looking for is we got that C3 equals minus 1, which does in fact prove that C sub n is equal to minus 1 to the n for general characteristic equations. N was 3 this time. So yeah, C sub n is just minus 1. Then C2 was T11 plus T22 plus T33, so that is actually just the trace of T, which we calculated before. C1 was this absolutely crazy term that pretty much has no significance, but it's all there. And you can copy that down again if you want. I'm not going to, but that's the that's the C1 stuff, I should say. And then C0, that's just the determinant again. So that's kind of why we calculated the determinant in the first place, is so that when we come back here, we get to this point, we recognize that that's just the determinant again. So yeah, all of these are pretty cool. Okay.